All right, good morning, guys. Today is Wednesday, the 27th of May. If you looked at our schedule, we know that today's a little bit strange. We went from page 422, and we're going to jump all the way up to page 437. We're going to skip lesson, lesson 21. It's not that I don't want to do it, not that it's not valuable. It's just we're really constrained by time. And if we're going to kind of cut something out, I decided to cut that. Because I wanted us to just we'll start looking at some different strategies. I mean, not strategies so much, but just different problem solving with word problems, because kind of contextual, using some of these skills within the real world, and get some practice doing that before we move on to other skills. So we're going to be doing pages 437, 440, 441, and 444. So even not only are we skipping ahead a bunch of pages, but then for like this lesson, we're going to do a page, skip a couple pages to another page, skip a couple of pages, and kind of move through some of these sessions, sessions 1 and 2 really quickly, and just focus on problem solving here. So I'm going to go ahead and share my screen, and let's get started. All right. Okay, so let's get started here. There's a couple different ways that we can model and solve these problems, but we're going to look at a couple different ways. Let's start here. Okay, so again, the lesson is multiplying fractions in word problems. So right away, you know that we're going to have to multiply the fractions, but we're going to talk about situations where it doesn't. Well, you don't know that necessarily, as it tells you right in the top of the paper. But in other situations, it's not going to tell you what operation to use, and you have to determine what that is. And we'll look at some of the ways that you can determine what operation to use by what we see in this problem. Let's read it. It says, Grayson lives 4/5 mile from the park. He has already walked 3/4 of the way to the park. How far has Grayson walked? Use a visual fraction model to show your thinking. So this wants to have some sort of visual model that shows and explains that you understand what it's actually saying. Okay. Now, the first thing we want to talk about here is what are the words saying that indicate that we need to multiply, because we need to multiply. Okay. It doesn't follow a lot of the same terminology, things like that from the past when we multiply with whole numbers and so forth, right? And so like, 3 groups of whatever, things like that. Often what kids will do is they'll say, oh, he lives 4/5 of the mile, he's walked this far. So they'll be like, oh, so I'm going to take 3/4, 3/4 subtracted away from 4/5, or 4/5 minus 3/4, and that's going to give me how much it is. Well, the problem with that is that this 3/4 is not 3/4 of a mile. This is 4/5 of a mile. This is not 3/4 of a mile. This is 3/4 of the way. That means that's 3/4 of 4/5. 4/5 is the way, right, from his house to the park. And so 3/4 of that distance is what we're trying to figure out. If this was 4/5 mile and then he walked 3/4 of a mile, then we could subtract it, but that's not what this is saying. He did not walk 3/4 of a mile. He walked 3/4 of the 4/5. So in order to figure out how much he's walked, we need to figure out what 3/4 of 4/5 is. So I'm going to go and put an H here. We'll put a P here. This is going to stand for home, and then the park, the distance that he's going to travel. So I'm going to use just a box that's a little bit squiggly apparently, that shows a starting and end point. Okay. For this thing here, we have fifths, right? So we're gonna break it into fifths. So it's 1, 2, 3, 4. So I'm gonna say that's broken into fifths because it's 4/5 of a mile, right? And I'm gonna extend this out even further. Here. Nope. Go ahead and redo this. I don't like this one. This isn't doing what I want it to do. See, we make mistakes, and mistakes are okay. We're gonna do this instead. We're gonna go home. I'm gonna say park. Now we're gonna do this. before I drew my lines, I need to do, this would be better. This is going to be 1. This is 1 mile. Okay, this is going to be 1 mile. So the park is not at the full thing, right? You always put the p at the end afterwards as well. The point is that this is 1 whole mile, so this would be 5/5. This would be 5/5 to show 1 mile, right? This is going to be 4/5 because he lives 4/5, correct? So we're going to go ahead 4/5. This is going to be my 3/5. This is going to be my, 2/5 and 1/5, right? So 1/5, 2/5, 3/5, 4/5, 5/5, right? Okay. So now we're good, right? Here it shows from home to the park is 4/5 of a mile. To here would be 1/5 of a mile further than the park. But I'm just showing this to show a whole. We really don't need this. I'm just using this to show that that is 1 whole mile, and this is 4/5 of the whole mile. But we're only concerned about going from this point to this point, right? Okay. Well, since we're ignoring this right now, this is already broken up into fourths, isn't it? It's already broken up into fourths. 1, 2, 3. It's already broken into 4 parts for us. That makes it really easy. Okay. How far are they along? Well, they are 3/4 along the way, right? 1, 2, 3 out of the 4 parts, right? Okay, this part section right here, if that is 4/4 of the way, right? This right here would be 3/4, right? So how much of a mile have they walked? Well, as you can clearly see when I color this in, 3/4 of 4/5 is actually has an actual value of 3/5, right? Now, drawing this model is just kind of showing that, hey, this is the distance, this is the amount of this distance, right? But I know a lot of you might just go ahead and use the area model, which would be fine too. So if we use the area model, let's just assume this is 1 by 1 by 1. It's not drawn very well. Good. If we go ahead and do this, and we go ahead and say this is fifths, 4 lines, 2, 3, 4 lines, right? And we're going to go 4/5, 4/5. Then this way, we're going to go ahead and go 3/4. So we're going to go 3 lines, 1, 2, 3, 3/4. Okay. So this is where it overlaps. Right here, we can see this is where it overlaps, right? Right there. Well, what do we have? We have 3 by 4, so we have 12. And then we have 5 by 4, right? 5 by 4 over 20. Well, we had different answers. This is 3/5 and this one. Well, we have to simplify, don't we? Okay. So if we're going to simplify, what number can go into both 12 and 20? We talk about our multiples. Well, both numbers can be divisible by, they're both divisible by 4, right? So if I divide by 4/4, right? So that if I divide by this, okay, 12 divided by 4 is 3, 20 divided by 4 is 5, and there we get the same answer. Okay. Naturally, if I just multiply it across, I would get the same thing, but idea of modeling something that works. Obviously, you saw that I made a mistake in my modeling. That's fine. We all make mistakes, right? Okay. I just had to adjust because I'm using pen. Normally, I would just erase, but I'm using pen so you guys can see better. Okay. So obviously, if you need to, we can look at this in different ways. You can always go back. Your task is going to be to do page 440. Okay. So 440, I'm going to go ahead and skip 440 right now, go to 441. Okay. And so just doing this problem here, so you're going to be doing 440 and 444 on your own. Okay, I'm going to be doing 440 and 441 with you, kind of just setting up those two different sections, right? So we had another problem here. It says Brandon's mother left 3/4 of a pizza on the counter. Okay. If Brandon eats 2/3 of the leftover pizza, how much of the whole pizza did Brandon eat? All right. Okay. So he's going to eat, just like we did on the last one, right? So this is said this is being a distance. This is an amount that is just sitting on the table here, right? So she left 3/4 of a pizza, right? So if we kind of draw a pizza here, it's going to be probably not very pretty, not very accurate. So if we break this into fourths, right? There are 3/4 of this pizza. I'm going to lightly shade that in. This blue color is what we had to start, okay? This is how much pizza we started with that his mother left on the counter. She just left it on the counter. You don't leave food on the counter because Brandon just comes and eats it. Apparently. Come on, Brandon. Anyway, here we go. So if it's 3/4, of the pizza, right? Let's see here. Let's see what he had. Oh, he left 3/4 of the pizza on the counter. He eats 2/3 of the leftover pizza. How are we going to do that? Well, if this is what we have, 3/4 of the pizza is what we have, right? Okay. And she eats 2/3 of the leftovers. That means of what's here, we could break this into thirds, right? So it's another way to look at this. Okay. If I break this into thirds here, right? Well, yes, I could break this into thirds too, but we're not going to worry about it. This is all relationship to a whole. So we understand what our total parts are, right? So I had the blue sections, which are fourths, then I broke those up into thirds, right? So this gives me the value of each piece. Well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it means each piece is worth 1/12, right? But how much of the whole pizza did Brandon eat? So again, he ate 2 out of every 3, right? So if he ate this one, 1, 2, he ate that one, he ate this one, then 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 he ate this one. Okay. Well, he ate 1, 2, 3, 4, 5, 6. He ate 6, and each piece is a 12th. Therefore, he ate 6/12, which is equal to divide both of them by 6, because 6 is half of 12. We get to a half, so we eat half of it. Well, you might be like, well, Mr. Smontress, there's an easy way to do it. And you're like, yes, you're right, there was. If I was looking at this as, again, 3/4, real fast here, okay, there's 3/4. He ate 2/3. Well, if we, of this 3/4, since we're not including this part, if we ignore this part now, we understand these are fourths, but if we just ignore this because he doesn't have it, they're already broken into 3 pieces, right? So 2/3 of this he would eat 2 of the 3, right? Well, what are 2 of these parts out of the 4? Well, it's 1/4, 2/4. That would be equal to 2/4, which is also equal to 1/2. So he ate half. So how much of the whole pizza? I should have clarified that. That's one thing I didn't clarify. How much of the whole pizza did Brandon eat? So our answer needs to be in relationship to a whole in this one. The last one, it was how much of the mile or whatever did he walk, or how much of the way is he at? This is in relationship to the whole. So it's important that we do relate it back to the whole. Okay. So hopefully that's clear. Hopefully. If not, come see me this afternoon. We can talk about it. So again, in your book, they do talk about other strategies and different ways to look at it. With these sections here, guys, don't hesitate to stop and look before you skip pages at some of the other informations, okay, that talks about different things. If it's helpful, again, I didn't have to stop and do this. Fraction of a fraction. This has a bunch of different examples of fractions of a fraction. If you do want to do that, I'll throw this on the screen real fast. It is not required, but there, you can pause that or whatever. But there are some examples of fractions of fractions. We've been doing this already with our models and everything. So just showing that is something that you can do, right? So on that next page, it shows the same thing we just talked about. So your task is going to be to do numbers 7, 8, 9 on page 44, 7, 8, 9 on page 44, and on page 40, what page was it? 430, 440, sorry, 440. There's 2 problems on page 440. And actually, really, the bottom one just says, check your answer. Okay, that's just saying, solve this problem in another way to check your work or check your logic in some way, shape, or form. So really, there's just one main problem on this page, and then there are on 444, there are 3 problems. There are 3 problems on that page there that you need to do. So again, if you watch the video, we do 2 of them together, then you just have those other 4 problems really to do on your own. Okay, I'll be online here around noon today. Hopefully some things sometimes pop up. I have a meeting before that, so hopefully I won't be late from that. All right, guys. Have a great day. Talk to you later. Bye-bye.